At the end of the previous video, we were working on the access control problem. This issue where we want to give the rectangle type complete control over how it is used and what you are allowed to use it for. And we have this way now of defining member functions that can return bits of data that are either returned directly from the data that's in the object or computed on demand. And you'll observe that there's no way for me to know in main whether getWidth is doing some arithmetic or whether it's just sending me back some data that it already has. GetWidth, getHeight, and getArea all look the same to me. That is an example of encapsulation. One problem that we saw at the end of the previous video, though, is although we can prevent people from sending in invalid data into the constructor, what is stopping them from setting the width to a negative value later? If we just have a member called .width, we're familiar with the structure view of the world, with the bucket of data interpretation. We just go into the structure and modify one of the members to be negative. So how do we prevent that? Let's take a look. I'm going to try compiling this. And we'll notice that now this assignment that in the previous video was valid on line 65 generates a compile error. So I've done something between videos that prevents this operation from occurring at all. What I've done is implemented access control. So go back and take a look at this. And I'll realize that I made a last minute switch from double to float, and I'll just switch that back. There we go. So what I have now is the same functions we had before. So I've got my default constructor. I have my parameterized constructor. I've got my getWidth, getHeight, and getArea member functions. There's another function I want to write in a minute, which we'll do in a minute. And then here are my members width and height. But notice, now I've got this word before them, private. And you saw in the previous video, there was that word public up here. And when I define one of these smart objects, whether it's a class or a struct, because I'm actually allowed to say struct here as well, I am allowed to decide, as part of my encapsulation, I am allowed to decide which members are visible to the outside world. And I do this by putting them into sections. So I put public and I list a bunch of public members. I can put private and list a bunch of private members. Normally, I think it's a good idea to group them all, but you are allowed to alternate back and forth. So I could do something like this if I wanted to. And there are sometimes good reasons to do this. So what I do is I just put public colon, and then every member appearing after that, before the next access control specifier, is public. If I get into a private section, all the members in there are private. Then I can go back to a public section and define more public things. And I can go back and forth. For the time being, we're going to talk about public and private. There is a third access control class called protected that'll come up later in the course. So if a member is public, anybody that has a rectangle is allowed to use it. The member getWidth is public, which means anybody who has a rectangle can call that function. If the member width was public, and actually let's get that assignment statement. I'm actually going to undo myself all the way back to here. Let's put the private section back down at the bottom of the class. And if I now I restore that assignment statement that was invalid before. So if I try and assign a negative width. Now, just notice that it's not that the compiler is saying that you are not allowed to set width to be negative. It's simply saying you don't know what this is. If a member is in the private section of the class, nobody is allowed to even know that the member exists unless they are inside the class. So outside, in main, for example, when you have a rectangle object, you are allowed to know nothing about the member width. You're not allowed to use it. You're not allowed to set it. You can't do anything with it. As far as you're concerned, it doesn't exist. On the other hand, if I set width to be public by adding it to a public section, and then I try to compile, now this works, and if I run it, then I get the altogether disappointing negative width in my rectangle. So what I'm doing here isn't specifically constraining the width to be positive. I'm just forcing the outside world not to see this. They're not allowed to see it, which means they can't set it to be negative. That means anybody that modifies width or height has to be a member of this class. And of course, it's still true that I have to make sure that nobody inside the class changes width or height to be negative, but that's way easier. I no longer have to worry about the general public. So we'll just compile this again to verify that it does indeed complain. There we go. It says, sorry, on line 65, you can't change rectangle.width because it is private in this context. So we'll delete that. Now, that said, if we scroll up a bit to, let's say, a constructor. So the constructor is a member function. It's inside the class. If you are inside the class, you are allowed to use every member of the class, including the private ones, as if it were just a local variable. So I'm allowed to use width and height inside the class just without any modification. So I don't even have to worry about, just because they're private, there's no need to treat them any differently. So I can set width, I can set height as long as I'm in the class, but because they're private, nobody outside the class can modify them or even look at them. And as a result, if I want somebody outside the class to see my width and height, I have to provide some alternative option. What I've done in this case is define what are called getter functions. So get width and get height. That was the point of defining those in the previous video. Get width and get height are functions. They are public members of the class. Anybody can call them. But because they're functions that return a double, in this case, notice how it's not a double reference, so it's a copy of a member, nobody who calls get width could leverage that to modify the width. They can look, but they can't touch. And that means that I can use this getter function as a clever way to prevent anybody from modifying the width except when I say so. They can still grab the width whenever they want, but they can't modify it except when I say so. And so the combination of that and the private and public access control does allow me once and for all to prevent anybody outside of the rectangle class from giving the rectangle a negative width. Of course, inside the rectangle class, I could still make that mistake, but suddenly I've really narrowed down the areas where that mistake can be made. And as long as I write the rectangle class carefully and I test it properly, it's very likely I can prevent the mistake from ever occurring. So if you try and construct a rectangle with a negative width, I prevent you by throwing an exception, and I then prevent you from ever modifying the width after the rectangle is created. I could also add a function if I wanted to allow you to modify the width. I could add a function called setWidth. And I'm not going to do that in this example, but I'm just going to sketch it out. If you give me a new width, then I could set, because I'm inside a member of the class, I could set the width to be the new width. And you can call setWidth because it's a public member. And I could also verify, so I could say if the new width is negative, then I'll throw an exception. And we know that if the exception gets thrown, obviously the new width would not get set. So I could use this. I could use a setter function as a way of controlling when the width can be modified and how, and by whom. In this case, if set width is public, anybody could call it. That doesn't mean they're allowed to set the width to be negative. So what I've done is I've shielded the real data. Instead of the rectangle just being a bucket of data like it was before, I've shielded the actual data inside the class behind all of these member functions that can act as gatekeepers. They can decide what you actually get, so whether you just get a copy of the data or whether you're allowed to modify it, and then what modifications you're allowed to make. And that's one of the key facets of encapsulation in C++ is this access control. Okay, so we're going to need that from now on. We're going to basically default, when we're writing our classes, to making everything private except stuff that you want the general public to have access to. So by default, we'll want things to be private. And then we'll define functions that provide limited access to those things. In the meantime, though, I want to do one more thing with this example. So it says add a static member function, create unit square. What's that supposed to mean? Well, I'm going to begin by writing a function out here that does what I'm asking. So I would like a function. Suppose I find myself creating lots of rectangles that have width and height equal to 1. So there's squares. Suppose I say I'm going to do that so often, I want to make a function that does that for me. So I make a function called create unit square. And it takes no arguments because it just does one simple thing, which is it makes me a rectangle with, we'll call it S. No, actually, we'll call it the result. It makes a rectangle with width and height 1, and then it returns it. It shouldn't surprise us. Of course, we can return objects of type rectangle. They are just like any other type. Okay, great. So I've got this function create unit square, and I'm going to return a rectangle from it that has width 1 and height 1. All right. So then I'll just test that out. So I'll say rectangle. We'll call this one S, and I'll initialize that to the result of create unit square. Okay, so I call the function, get back to rectangle, and then I'll just try and print it out. So I'll just I'll duplicate these print statements. So let's see, S has width, S has height, S has area, and then I just sub in S for R2 here. Okay, so that's the first thing. Now, all we've done right now is just written a function that works with rectangles. That shouldn't surprise anybody. We should have known that we could have done that. And sure enough, it does work. It calls the parameterized constructor, and then it sets width and height to be 1 using the parameterized constructor. Okay, a couple of things. The first thing is, what if I impose a bizarre arbitrary constraint? Like I say, try this again, but do not use the parameterized constructor. And recall that there is no way to set the width or height of a rectangle unless you use the parameterized constructor. Because once the rectangle has been created, once the constructor has been called, you, as a member of the general public, have no way of modifying the width or height because we haven't provided any mechanism to do that, and the actual width and height data is private. So it's an odd restriction I've imposed, but let's consider this restriction. And then second, let's think about issue number 2 from that earlier video. I talked in the earlier video about the various reasons the bucket of data approach is a bit of a disadvantage. One of them is if I make a bunch of functions that sort of are part of the rectangle, I mean, this goes with, conceptually, this does sort of goes with the rectangle, having it floating around in the global scope can be a little bit confusing. Wouldn't it be great if I could mix this function in as an honorary member of the rectangle class? Now, it's not a member function, because obviously its job is to create a rectangle and send it back to me, but it is sort of part of the rectangle type. Wouldn't it be great if I could allow a regular function to live inside of the rectangle class? And it turns out I can. So I can put it inside the class like this. But I want to differentiate that it's not a member function, because to be a member function, it has to operate on a particular rectangle, which makes no sense, because when I call createUnitSquare, I don't have a rectangle. I want you to create one for me. So instead, this is a regular function. It's not a member function, and I will indicate that with the use of the keyword static. When I define a static member function, I'm defining basically an ordinary function that happens to live inside the class. It's not a member function. It's just a regular function that happens to live inside the class. So I'm going to begin by testing out the static keyword, and then we're going to take a crack at this. So when I call a static function, it's not a member. I mean, it is a member of the class in a certain sense, a sort of honorary member, but I don't have a rectangle to call it on. I want to call createUnitSquare to create me a rectangle. So what I want to do is call the function createUnitSquare that lives inside of the rectangle class. So I want to go into the rectangle class, find createUnitSquare, and just call it. And so for a static function, I use this notation. Notice the double colon. That should ring a few bells. So the createUnitSquare is inside of the rectangle class. Just like how when I use cout lives inside of the namespace std. So the colon operator is go inside of this group of names. So this namespace or this class. So when I call a static function, which is a regular function that lives inside the class, I have to name the static function by giving the name of the class and then colon, and then the name of the function I want to call. So we'll try that out. Here we go, and it still works. It still gives width and height 1. And what about that contrived exercise? What if I'm not allowed to use the parameterized constructor? And here's one other benefit of static functions. So this function, createUnitSquare, doesn't pertain to any specific rectangle, but it's an honorary member of the rectangle class. And what did I say earlier about private members of a class? I said you're not allowed to use the member width because it's private if you're outside in main. So the general public cannot use the members width and height. The only time you're allowed to use the private members of a class is if you are inside the class itself. And the question then is, on line 51, am I inside the rectangle class? And the answer is, well, yes. This function, this static member function, does live inside the rectangle class. And that means any rectangle object that this function comes into contact with, it is allowed to access the private members. So I can write the result.width equals 1, the result.height equals 1. Because I'm inside the rectangle class in one of the static member functions of the rectangle class, I am allowed to use the private members of that class. And so we'll try that. And we can see it doesn't give us an error. If this were just a regular function living outside the class, I would get an error there. I'd be told, sorry, you're not allowed to see .width. As far as you're concerned, it doesn't exist. But here, I've taken my regular function and moved it inside the class, and that means I'm allowed to have private member access if I ever come into contact with some kind of rectangle object. Now, we'll come back to static member functions later, because I realize that this isn't necessarily the best first example of a static member function, but I wanted to put that in there at least once here at the beginning to observe that inside of a class, I don't just have to have things that pertain to one specific instance of a rectangle. I can also bring in extra stuff like regular functions, the kind of functions we've been working with all along, that get to live inside that class. And we use that : syntax to work with them, and they're called static members of the class.